I can actually record it to this computer. Okay, so yeah, why don't I do that? Okay, so using classes and objects, as you know, in this class, we concentrate on classes and objects. That is really the focus, but we are doing the first few chapters just to make sure you switch from Python's syntax to Java syntax. Okay, that's what we are doing. So it's only the difference of syntax, not concept, okay, not logic. So using classes and objects, and we will discuss classes and objects more in depth in starting from chapter 4. We can create more interesting programs using predefined classes and related objects. So there is a library in Java, and in that library, you have a lot of classes that you can use. They are predefined, so you don't have to write them, but you can use them. String is such a class. String is such a class, and that's what we are going to discuss. And we will also discuss random and math classes, okay, and briefly wrapper classes. So that's what we will do. Let me put this. Okay. So creating objects, how do we create an object? Okay, that's what we will discuss next. Okay, if you remember, this is how you create an int variable, right? In Python, you don't have to have the data type. In Java, you must have the data type. You have finished your chapter 2 lab, so now you should be very habitualized to this. Always have a data type. So that is the data type, that is the variable name. This is called a primitive variable because it's built in the language. Okay, now a class name can be used as a type to declare an object reference variable. So here, this is different from this one because this is not a primitive data type. It's not built into the language. It's written using the language. That's the difference. You know, int is in the language. When you use this language, it's right there. But string is a class that's written using the built-in data types and language. So it's in the library of Java. It's not a primitive data type, it's a class. And this is the variable name. The declaration procedure, they are the same. Data type, and here is class type, right? And variable name. So here we call this a reference variable instead of simply a value variable. This is called a reference variable because in this variable, instead of storing the value of this string, it stores the address of where this object is. We will discuss that later. So no actual object is created with this declaration. So title right now has no content. It's empty. We call that null. Okay, that's a key word actually. So title is null, meaning it does not have an address to where the content is because it does not have any content yet. An object reference variable holds the address of an object. Okay. The object itself must be created separately. And this is declaring the reference variable, and title right now is null. This is creating the object. Okay, so you learn the scanner, right? You know how to create a scanner class. And here, this is creating a string object. So new instead of scanner, because the type is string, you use string. So new string, and this is called the argument, right? The parameter, the argument. So this title now will contain this content, will reference this content. So this is how it works, okay? When you declare title, right? This is a string reference variable. It doesn't have any address yet. When you are doing this, it's null. So there is nothing. And when you do this, when you do this statement, you're creating the actual object. The system will find a memory location and put that content there, the string there, and that memory location's address will be placed in this variable. Does that make sense, everybody?
Yes.
Okay, so a reference variable contains an address. And that address is where the actual content is. Okay, I'm just putting a random address. This is not a valid address at all because it's a decimal number. It should be a binary. But anyway, so 1, 2, 3, 7 is the address of this, the first byte. It's actually, okay, so it's a contiguous sequence of bytes. And this is the first byte. So when you reference title, the system will look at the address and go to that address, get the content. Okay, that's what this is. For string, it's a class. Remember, a string is a class. Okay, we say the string class, right? The string class. So it has methods. And one of the method is called length. And you have this in Python, but it's a function. Remember, in Python, it's like this, right? And you have the variable or string literal. Remember, in Java, you will never have something like this. You will never have a function. It's always a method, and a method always belongs to a class. So this, you will not see this type of syntax. So in Java, it's always a method, and that method belongs to a class. In this case, length belongs to the string class. So when you use length, you have to use a string object. Okay, so this is, it's the string object. It's object already, right? It's a reference variable, but it's pointing to an actual string object. And dot, that's the syntax, length. Okay. Without parameters, you still have to have the parentheses. So this method will return an int, and that int will be placed in this variable. Okay, any questions? Okay, so a method invocation can be thought of as asking an object to perform a service. So you're asking title, which is the string reference variable, to provide you some service, which is give me the length of you, right, of yourself. So that's what this is. Okay, so now let's look at this. So this is showing you the difference between primitive data type variable and a reference variable. Okay, so we said int, this is a primitive data type variable, and 38. When you do this, this is what happened. This is what happens. So this location, okay, it's 4 bytes, a 4 bytes location. It's named num1, that's a symbolic name. And then in that location itself, it has the value. Versus when you do this, when you do string name1, this is a string reference variable, and then you create the object right there. So now this name1 will have an address that points to the content, where this content is. So in this case, name1 doesn't have anything but the address, and that address is where this is. So that's the difference between a primitive data type variable and a reference variable. Okay, any questions? So if this location is 0, 1, 0, 1, 0, 1, then here it will be 0, 1, 0, 1, 0, 1. That's the address. So you look at this address and you go to the system, okay? It will go to that address and get the content. That's the difference. So one is primitive data type value. This is a primitive data type variable, okay? It stores the value directly. One is called a reference variable. It stores the address of where that actual object is. So the act of assignment takes a copy of a value and stores it in a variable, right? So when you do this, you're assigning this value into num1. When you do this, you're assigning this value into num2. They are two int variables. We discussed this syntax comma to separate the same type. Okay, so when you do num2 is equal to num1, you are taking the value from num2 and replace the value in num1 with it. So after this assignment statement, okay, it's like this. You're putting the value itself in that location, right? Okay, this is primitive data types. Now let's look at this reference assignment, okay? Reference assignment, because this contains an address and this contains an address, so this is pointing to somewhere in memory where it has this content, and this points to a memory here. Okay, so when you do this assignment, you are not assigning this actual string to it. You are assigning the address contained in num1 to this reference variable. So that means num2 now, num2, no, not num2, name2 will contain the address from name1, right? So name2 now will point to the same address as name1. I will let you think about that and see if you understand it. So if this is 0, 1, and this is 1, 0, okay? So this location is 1, 0, this location is 0, 1. Now, when you do this, you are not assigning this string to name2. Excuse me. Let me. I just need to clear my throat. Okay. So when you do this, okay, you're not assigning this string to name2. You're not assigning this string to name2. You are assigning this address to name2, right? Because name1 has address of 0, 1. So now name2 will have that address. So name1, here, where? Here. Okay, name1 has 0, 1. And name2 has 1, 0, but because of the assignment, now name2 has 0, 1 also. So they point to the same location. So that means this is not pointing to this location anymore, right? So here you have a phrase, a name named Steve Wozniak, the first programmer for Apple, and he is not being pointed by any variable. So this is a piece of memory that's floating in the sea and no one knows where he is because you don't have a handle to it. Your handle for name2 is pointing to this location now. So this location is really lost. And when it's lost and not referenced, it's not referenced by anyone, it will become garbage and it will be garbage collected. Sorry, Steve. Okay, so two or more references that refer to the same object are called aliases of each other in the previous slide, name1. So name1 and name2 in this case, they are aliases. That means they refer to the same thing, just like you have a formal name and sometimes you say, I would like to be called by Heather. I just remember this, Jesus. So you are Jesus and at the same time you are Heather. And if I say Jesus, that's you. If I say Heather, that's you. That's the aliases, right? Okay. And that creates an interesting situation. One object can be accessed using multiple reference variables, just like a person. Okay, I explained that. but you should manage aliases carefully. The reason is changing an object through one reference changes it for all of its aliases, because there is really only one object. I cannot use string to give you an example, because string is a specific different class because it's immutable. So this doesn't apply to a string. It will apply to other classes. So what that means, if this is another class, okay, if you change this object using name 1, when you reference name 2, it will be changed. Also, it will be changed to something. That's what that means. Any questions so far? And I already talked about this. So in Java, you do not have a memory leak. In C++, you will have memory leak, because if you declare a pointer and you do not delete it, you are not reclaiming the memory, and that memory is always being used. So gradually, if you don't clean up yourself after yourself, your memory will be used up and you will not be able to do anything, because it will say memory is low, virtual memory is low. That's because you used up all memories. So you have to remember to release them, deallocate them. While in Java, you do not need to do that, okay? Garbage collection, automatically, it collects it. And I talked about this already, and you can, if you don't understand it, do you understand this, this concept, everybody?
Yes.
Yes, ma'am.
Yes. Okay, good. We will go on, and you can always come back and look at this. I'm trying to put detailed explanation here, right? Okay, let's go to the string class. That's creating the objects. Let's go to the string class. Okay, because strings are so common, we don't have to use the new operator when creating a string object. Move this. So you can directly do this. If you look at it, string title equals to the string itself versus this syntax. Okay, both of them are correct, but this is creating a new object. This is simply assigning this object to this reference variable. So they are both okay. This is this syntax, just like you declare and initialize a primitive data type variable, but this syntax only applies to string. Okay, for all other objects, you should always use this new class name syntax. We apply this syntax to string because it's used so often, and we simplify the language. The developer, Java developers, Java language developers simplified it. Okay. Okay, so we discussed that. Okay, here is another thing. Strings, okay, strings are immutable. That means once you declare it, you create this object, you cannot go back and change that object. So if you want to change it, it becomes a different string. You have to assign it to another variable, and we will look at that. Okay.
Professor, I have a quick question.
Yes.
I'm not following along what the difference between the first one and the second one is.
Oh, okay, the first one, remember, how do you declare a scanner class? Think about it. You have to say scanner, right, in input equals to new scanner, right? You have to do that and system.in. This is how you create an object. Okay, that's the syntax. You have to have the new operator followed by the class name. That's the syntax. And for string, it's the same. That's the syntax. New operator, the class name, and followed by the parameter. So that is the syntax. But here, we are using a different syntax. We are not using the new operator. We are not using new string. We simply assign a literal string or string literal to this variable. This is the same as this, right? It's the same syntax. You're assigning a literal value to a variable. Here, you're assigning a string literal to a reference variable. This is permitted because string class is used so often. This applies only to strings, not to other classes. That's
Okay.
the difference. Okay.
Okay, I got the top one, but when would you use the bottom one?
You always use the, oh, you mean with string? It's really your preference. It doesn't matter which one you use.
Okay, got it.
Yeah, because string is a class, so it's always valid when you do this. And you have to know both of them, of course. But you can also simply do this. Let me stop for a minute. I don't know why my voice. Okay. Okay, so you can use either one of them. Okay.
Okay, thank you.
Let's go to the next slide. Okay, string indices, indices actually. You understand this, we did this in Python, so I don't need to explain that much. Each character occupies a position index, okay? It always starts with 0 and 1, 2, 3, 4. So you understand that, right? Everybody, I don't need to explain this. Okay, let's look at this, class, okay? This example. So I'm going to explain it. Okay, string phrase, change is inevitable. That is declaring and initializing this phrase reference variable. And then we declare 4 variables. They are all strings. Okay, and then we print out the original string. And this is for the quotes, right? So that you have the quotes here, you understand that. Okay, and this is called a string concatenation, if you remember, right? We combine the strings together. And length of string plus, this is an int, and you can directly concatenate it with a string because this is a string. So phrase dot length. And this will be the number of characters of this string, and that is 20. Okay, we don't have to count. That is 20. That will give you the length. Okay, and now we do phrase.concat. That means we want, concat means concatenation. We want to combine this string literal with phrase, and phrase is change is inevitable. So if you look at this, this will be change is inevitable, followed by a comma, and followed by except from vending machines, right? So that is mutation 1. Now this combined string will be assigned there. And so when you print it out, okay, mutation 1, you will see it is like this. Okay, questions? Okay, and then mutation 2 is equal to mutation 1 dot to uppercase. In Python, you have the function called upper, and here it's called to uppercase. So mutation 1 is this string, everybody. That's mutation 1, right? We got it from this statement here. So mutation 1 dot to uppercase, it will change mutation 1 to the value of mutation 1 to uppercase temporarily and assign that returned result to mutation 2. So when you print up mutation 2, it's like this. Okay. But please know that mutation 1 did not change to uppercase. Remember, that's what we were saying. Strings are immutable. You cannot change a string. So phrase did not change. It still is change. It's inevitable. And mutation 1 did not change. It's still this string, okay, like this. It's not in uppercase. You cannot change it. You can only call the method on the value of that string and assign it to a new variable. So now mutation 2 is a new object. So mutation 1 remains the same. Phrase remains the same. And that's why we say strings are immutable, okay? And then mutation 3 is mutation 2 that replace E with X. So if you come here, mutation 3, if you print it out, all the E's become X's, right? They are changed. So that's what this is. All the E's are changed to X's. Okay, so that's the replace method. So once again, mutation 2 did not change, and that's why when you print it out, you see it's still that, right? Mutation 4 is mutation 3, that substring 30, and you understand substring. In Python, we have substring also, but the difference between this and Python, I forgot Python, does it include the last index or not? I forgot. I have to go back and look at it. So for Java, this beginning index is included. For this index, it's excluded. So you are looking at the string beginning from index 3 to the character before this index. Okay, so mutation 4 is mutation 3, and here is mutation 3. You will count 0, 1, 2, 3. That is n, right? You start from 0, that's n. So beginning from there, you go to where? 29, including the character at position 29, which is this. If you count, okay, that's what that is. So this is 29, this is 30, this is 31, 32. So this, the key to remember for substring method is this is not included, it's exclusive. Okay. Any questions, everybody? No? Okay, and when you print out, you can see mutation 1 never changed, right? Even though you used it to call this method, that returns you a value, but that variable, that object did not change because strings, once again, are immutable. And this method, all these methods return a value, give you back the value. The value of mutation 1 changed, but mutation 1 itself does not change because it points to that address and that doesn't change. Okay, so when you print it out, you see it's still the same. Mutation 2 is still the same, 3 the same. Even though you called methods on them, they did not change. And the length, okay, 27. So that's that. Any questions, everybody? No?
I do have one question. So I might have missed it. So the dot length parentheses in the original system out print line, that's actually calling from an action, right? That's not a whole separate thing that you have to declare.
This is a method.
That's what I meant.
Yes.
Action method. Sorry.
And when you call a method of a certain class, you always use a reference variable in that class. So phrase is a class, is a string.
Right. That you, yeah, I got that part. I just didn't know where string or the length came from, but
length is a method, just like
okay,
these.
so it's already in
Okay,
there.
they are all methods from where? From the string class. That's why you can use them.
Okay.
Okay, and this is also a method.
Okay.
So length is a method, concat to uppercase, they are all methods. That's why you can use them. Okay, good question. Any other questions, everybody?
But the length is already there, like it's always there, right?
It's already written. You don't have to worry about it. It's already written by the Java language developer. You know, Java and Java always changes, right? You download, you can see all the different editions, different versions. That's because they keep adding and modifying the language library. So this is in the library already. You don't have, just like you want to use some information, you want to use a tool, you have a toolbox. You go there, get the tool and use it. You don't have to make that tool yourself. And this is the same. This length method, it's a service, it's a tool. It's already in the string class. And the string class is already written, or we say defined by the Java language developer.
Got it, thank you.
Okay, and here is the difference. When we say the language, Java language developer, they are responsible for, for writing that language itself. We are, in that sense, and the end user of that language. We develop programs using the language they developed. right? So when they developed this language, they already wrote the string class. Okay. So here are some string methods examples. Okay, I'm giving you these examples so that you know how to use it. This is declaring two string reference variables, and the sub doesn't have a value yet, but S has a value. Good morning, right? Okay, and now because here is a method called index of, and we have this in Python also. Index of will give you the position or index of a certain character. So in this case, I'm looking for the index of an empty space. And if you look at the string S, which is S, right? Okay. So the index is at 0, 1, 2, 3, 4. So position will have the value of 4. You're assigning that to position variable, right? Okay. And then sub is a string reference variable we declared, but not initialized yet. Now we are putting this substring to it. So as substring from 3 to 7, let's see, 3 is D, right? 4, and then 5, 6, 7. 7 is R, but it's excluded, remember. So we will have D space M O, okay? And that would be the substring. Do you have any questions, everybody? So no. Sub, no, okay. Sub will have this value now. And S still has this value. It didn't change. And then we will do sub is equal to S dot substring 3. Substring is a method, everybody. Okay, spell out fully substring. And this means you start from 3 and you go all the way to the end. So this will have this string. If you do not have a second index, then you go all the way to the end. Okay.
Actually, I do have one question.
Yes, go ahead.
Int position equals S index of, and then you find the space character, right? Mm-hmm. Like, so it's calling out a position or an integer named position, right?
Yes, it's assigning the value that is returned by this method call to this int variable. Yes.
So position now equals 4.
Yes. Position now has the value of 4. Yes.
Correct. And then where do we use that later on?
We are not using it yet. This is just an example.
Got it. Okay. Thank you.
Okay. Okay. So char, you remember, is a character.
I also have a question real quick above.
Go ahead.
So when it says like sub equals S dot substring 3, 7, and then you move on to sub equals S dot substring 3, isn't sub already an immutable string, so you couldn't like change it a second time?
That's a great question. Let me explain that. I'm glad you were thinking about that. Okay, so when you do sub, this is sub, right? And it's pointing to a substring, and that is what? Okay, D dot MO, right? It's pointing there. Suppose this is 0, 1, and so now it has the action, the address of 0, 1. So that's what happens here when you do that. And when you do this, we are creating a new object. Okay, so there is a new place, and this may be 0, 1, 1. And this will contain the string of this. And now we are assigning that address here. So instead of 0, 1, okay, now it's 0, 1, 1. So this link is gone. It's pointing to this one. So this, no one is pointing to it. It will be garbage collected. Does that make sense, Scott?
Oh, okay. Yeah. So it just replaces the address.
Yes,
and then,
yes. The original string is gone. But you see, that object was not changed. It's not changed. Only no one is interested in it. So it's again, it's floating freely, and when the truck comes, it will pick it up as
Okay.
garbage.
Yeah, that makes sense. Thank you.
Okay. Okay, so here, character, and so this is a primitive data type value, right? And char@ will give you the character at a certain position. Oh, Jesus, here we are using position actually. It doesn't matter you use it or not, right? Usually when you get it, you want to use it. So here I'm using position, which is 4. So this is saying, give me the character at index 4 from S. That's the object. And assign it to character. So character will have the value of the empty space. Questions? Okay. And character, okay, it's now we are reassigning this. A sub, remember what sub has. Sub has this, right? Sub.char at 3. So at position 3, it's M. Oh, it's O? Oh, yeah, it's O. Okay, 0, 1, 2, 3. Okay, it's O. So now character has O. Okay, and that's some of the methods. Any questions, everybody? Can you hear my husband, everybody?
Just a little bit.
Yes or no?
Just a little bit.
Let me close his door. I will go there and close his office door. Okay, he is having a meeting right now. Okay, so now, do you have any questions, everybody?
I just have one. So when you're using the method substring, so for example, in the last one you said substring 3, that starts after character 3?
No, starts at index 3.
So then why wouldn't it be OD morning? Because character 3 is O.
Character 3 is O? No.
Because it's good morning?
I just went downstairs and now I'm out of breath.
No,
So S, see what S is, right? That's S.
right.
Okay, 0, 1, 2.
Oh, okay. Okay, I see.
Okay.
So we start at 0. Okay. I had G as 1. That's why. Okay.
Okay. Anyone else? No questions? Okay, let's continue. Okay, so this one, string S1 is equal to San Antonio, S2 is equal to San Antonio. Here I'm using an expression, okay, an expression without the semicolon. This is called an expression. So I'm comparing the two. When you compare two strings in Python, you can simply do this. In Java, no, because that will compare the addresses. So in Java, when you use the double equal sign to compare two object references, you are comparing the addresses. And when you want to compare the content, the object itself, you use equals. Okay, so S1 dot equals S2, this means whether the content of S1 is equal to the content of S2. And think about it, they are not equal. Why? Because this is uppercase, this is lowercase. Okay, Java is case sensitive. The characters, ASCII characters are case sensitive. So this will return false. Okay, and here, this is another expression. Remember, strings are immutable, right? So when you do this, this method will be executed. It gives you a value, but you are not capturing it. So the value just falls to the ground and disappear. So we call this an expression. If you want to capture that value, you have to do something like this. Assign it to a variable, right? Assign it to a variable. Okay, so this is not assigning it, so it's an expression. It will return good morning, San Antonio, but no one captures it. No one cares about it. S is good morning, and S1 is San Antonio. So that's what will be returned. Any questions? Okay, but here you are capturing the returned value by printing it out. This will print out good morning, San Antonio. Okay, Any questions? I put this here. So I have this here just to show you to run it. Okay. This one we already did, right? We did that name 2, name 1. You can see that when you say name 1, it's assigned the value. So, okay, let me unblock this part so that you can see. Okay. Okay, I'm going to run and you can see. Okay, so position index sub character. This is what we just discussed. Okay, and even though we haven't discussed if yet, we still can use this because you're familiar with if, right? So if they are equal, print out they are the same. If they are not equal, print out they are different. And this says they are different, right? Okay. Any questions about this? So after all this call as substring, if I print s out, okay, print system, print, that is Python system.out print line s, you will see it still doesn't change at all. It's still the same good morning. That's because strings are immutable and you cannot change it. You are simply calling a method on it, on the value in it, not the object itself. Okay, any questions about this? And if you print out S here, let's print out S. No, not S, sub, right? Sub. And you will see that. Oops. I changed something. Let's print out sub. Okay, you can see sub is the morning, right? Okay, so the original one is gone. Now we are using really this one. Okay, so if you print out char, let's print out character. Okay, you can see it's O, right? Okay, that is the running of that syntax of that problem. Any questions, everybody? No questions? Okay, let's continue. This is such a messy slide. I'm going to erase everything. Okay. What output is produced by the following? This is simply some review, right? Okay, and this is asking about the length. So you will just count, including the space, including the punctuation and everything. That will give you, it will print out. And string, substring 7. So string is this one. So we count 0, 1, 2, 3, 4, 5, 6, 7. It will start here, go all the way to the end. And this is string up to uppercase. And that means this will be made into uppercase and return, and you print it out. Then I'm asking you, is string str itself in uppercase?
No.
No. Okay, remember strings are immutable. You cannot change this object. You can only use the value returned by a method call on this object to another string variable. Okay, and string.length, it doesn't change, it's still the same. So that's that. Any questions, everybody? Okay. So the problem with next int, next and new line character. For this one, there is a problem when using one numeric scanner class retrieval method, next int, next double. Okay, this is because of the keyboard buffer, the location in memory that I'm just explaining it. So here is the problem. I'm going to show you. This is the problem. Okay, look at this example. So you understand this and this and this. So you're asking the user, please enter a word, and you enter. Suppose you entered hello. Okay, suppose you entered hello. Remember, next reads only one word, right? Okay, next int will read an int, next double, a double, next float, a float, next will read one word only, while next line will read the whole line, including the new line character. Okay, so here, when you enter hello, it will read hello itself. But remember, after you enter hello, you press enter to tell the system you are done. So the enter key will create this new line character. And it stays in the input stream because you're not reading it. You are reading one token, not the new line character. So you read hello, and the new line character is staying in the input stream. And then it will display this. And then this next line will read the new line character in the input stream. So you would not have a chance to enter anything here, because in your input stream, there is the new line character. And next line will read anything including the new line character and stop. So that's why it will read the new line character. So here you will not even have a chance to do anything. Okay, just know that. And then when you print it out, word and word again, you will only display hello. Word again will have nothing. It will be the new line character. So it won't display anything. Okay. And then you enter your age, next int. When you enter an age, you enter 25, for example. You press enter. 25 will go into age. The enter key will once again stay in the input stream. Okay. And so when you say enter a model, and this will read the new line character in the input stream. So when you print out you are and your model is, model will have nothing. It will be a new line character. That's the problem. So let me show you. Okay. Okay, so this is exactly what we just did. And so enter a word, I will enter today, right? Enter a word again. And you can see when it says enter a word again, that's this statement. And word again is equal to next scan.next line. It should wait for you to enter something, but it doesn't because it already read the new line character. So well, it doesn't allow you to enter anything. And when you print it out, see what it says. It's only today. There is nothing else, right? Okay, and so it will execute this statement, and you will enter your age. So that would be executed by this statement, and then it will display enter your model. And when you do this, it will read the new line character after you press enter, right? So enter model, you cannot enter model. And it will say system.out.println, you are this years old, and model is nothing. There is nothing. That is the problem. So to solve this problem, when you have this problem, here is what you do. You always simply just get rid of the new line character. To do that, you can simply do scan.next line. So you know after you read the next word, the user presses enter, and you just get rid of that new line character by reading it and discard it, right? And here is the same. After you read the next int, you get rid of the new line character. Okay, next line. Okay, so So now let's run. And you will see this time it will allow you to do that. Okay, today, and enter a word again, right? This time it allows you. Enter your age, 23, and enter a motto, something. So that's how you solve that problem. Any questions, everybody?
So you used scan next line after next int?
Yes, because next int, next float. Remember, when you press the enter key on your keyboard, you are creating a new line character. So you want to get rid of that so that you can read whatever you want the user to enter. Otherwise, it will not read that.
So
yes.
basically you're doing it scan next line right before you're trying to scan the next line?
Yes, exactly. You will do a next line, scan that next line right before you want to read something, next line, yes. But if you are doing next int, that doesn't matter because next int, next float, next int, next float, next double, they skip all white spaces. So they skip the new line character. But next line is the opposite, right? It reads everything up to and including the new line character. That's why. Yes, you can summarize it that way. When you want to call next line, make sure you get rid of the previous new line character this way. Okay, so this is, you don't have to always do that. When you have a problem like what we did, you see, I entered, it doesn't allow me to enter, then come back here and look at this example. Solve that problem that way. Okay, other questions? Okay, so here is the solution here. I put this here. Okay, so you simply add those two lines to get rid of the enter key. We will not do this example. I think I have some, I have a video about this, I think. So we will not do this because we don't have time. This is the online part. You will do it Monday, right? You will do this on your own. And I'm sure you can figure it out. So make sure you do the exercises, okay? Let's go to the random and math class, okay? Any questions so far, everybody? Remember, when you use the methods of the string class, always use the reference variable dot method name, okay?
So were you saying that programming exercises do, like we turn that one in?
No, not this one. This is just in-class exercises, but we don't have time to do it. Gotcha. The ones that are due are on Turing's craft. Okay, those are the graded exercises. These are just for your exercise. If I had enough time, we would do this, right? If this is not a hybrid, if this is a full face-to-face class, we will do this. But this is a hybrid, so I will leave these exercises to you. That answers your question?
Yes.
Okay. Okay. So class libraries. Let's go to the class libraries. I will take you to the library. Okay. 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 Go to java.oracle. You already know this because you went there to download Java, right? Okay, go there and then you will see, let's see, where we go. I'm looking for the Java, oh, it's not here. I'm looking for the library. Okay, it should be resources. Not here. Okay, let's go back there. The API. I'm looking for the API. I will stop this recording. Okay, I clicked on this. And did I go to documentation maybe? I think. I went to documentation. And API documentation. And this is a little bit different Java SE. Okay. Packages. I should be able to, I was there just now. I got myself out of it. I cannot click on any of them.
There is a link in chat that me and Autumn also linked that takes you back to where you were originally at.
Okay. Okay, so let's just, thank you. Let's click on that. Okay, good, thank you. Thank you very much, docsoracle.com, right? Okay, so here, if you go to the string class, everybody, this took 5 minutes. My precious 5 minutes were gone because of this. This is terrible. Okay. If you go to here and go to string. Okay.
Are we on a Java 15? Just to be clear. Okay. Yeah, I found the 15 one, and since we had the 7.2, so
okay.
Just to.
Okay. So this is string. Notice that this is string, right? And you can see this gives you explanation and all the methods. These are constructors. You don't understand yet. Constructors are simply method that allows you to create an object, and we will discuss that in chapter 4. But these are the methods. This is the return type. These are the methods. Char at. Let's look at char at, the very first one. Okay, so it says returns the character value at a specified index. So whatever that value is, it will give you the character, right? An index ranges from 0 to length -1 because the last character is always 1 less than the length. We discussed this in Python. The first char is at index 0. Okay. So this tells you what to do, how to use the method, actually, if you look at it, okay? So it's very useful, char at, okay, that doesn't matter. But you should only know the parameter, what it does, what it requires, and the value it returns. So by doing this, you can use a lot of methods that we have not discussed, and they're all here. This is a comprehensive library, and length, see, length, returns the length of this string. The length is equal to the number of Unicode units in the string. Okay, so this is the library. I will stop here, and you can look at it on your own. Thank you for helping me out to find it. Okay, so here, that's what this means. Okay, we will go on. Packages, and just now you saw the packages. Right? These are the packages. Okay. So a package is simply an organization tool. It's a folder that have the similar, have classes with similar purposes. That's why we call it a package. Okay. And when you want to use the library, you have to make sure you import it. And we did the import util java.util.scanner. You understand that? So we did that already. Okay. The import declaration. This is unnecessary because java.lang, this package is by default imported for you. So you don't have to explicitly import it. It's implicitly imported for you by the language, by the environment. But this means everything. This means, oh, here. This means everything in that package, every class in that package. Okay, so dot followed by a wildcard. The random class. The random class belongs to the java.util package, okay? It provides methods that generate pseudo-random numbers. A random object performs complicated, okay, we don't have to, so next int, this is a method, okay, will generate a number between this and this. Integer.main value, that's 2 to the 31st negative, and max value 2 to the 31st. Okay, so putting a seed value inside the parentheses will generate a number between 0 and that number minus 1. So let's look at examples. Random belongs to the util package. So what you do is you have to import, right? Okay. Let's look at it. Remember, all statements must be within the method. And here is the main. All methods must be placed within a class. Okay, so we declare 2 variables there, and we declared a random object, right? Right, that's the class name, variable name equals to new random, just like new scanner, new string, but random does not require a parameter, so you don't have anything there. So you use that object, that reference variable that you just declared and instantiated, and you call the method in the random class next int. This will give you a number this big in this range, that right? You remember. This will give you a number in this range. So it's a random, really vastly random number. And so usually you place a seed value in it. This means it will generate a number between 0 and 9 when you place a seed value. Okay, it always starts from 0 to 1 less than the seed value, inclusive. So this will be included. Okay, and this will generate a number from 0 to 9, right? So if it generates a 0 to 9, if the number, minimum number is 0, you add 1 to it. Now it's 1. And then if it's 9, the max value, then it's 10. You add 1 to it, right? If it's 5, you add 1 to it, it's 6. So that's how this works. That's why the number it generates will be from 1 to 10. Do you understand this, everybody? This will be executed first, this function call, method call. And then you add whatever that value is. And the main is 0, max is 9. So if it's 0, you add 1 to it, it's 1. If it's 9, you add 1 to it, it's 10. That's how this comes from. And this one will return a value between 0 to 14, okay? And then you add 20 to 0, that will be 20. You add 14 to, you add 20 to 14, that would be 34. So that's how this comes about. Okay, and now let's look at this one. This will generate a number between 0 to 19, right? Minus 10, that would be the main number it generates will be negative 10. The 19 minus 10 would be 9, right? Okay, so that's where this comes from. Any questions, everybody?
I have a quick one.
Okay.
So every time you're changing num1, you're changing the address, and all the above num1s like disappear, or
not address, because this
that's
is
right, not a string.
Primitive value.
Mm-hmm.
So just the value inside. It's
That's
just like a blackboard. You erase it, rewrite, erase it, rewrite. Yeah.
Okay.
Okay. And everybody understands this, right? And this one will generate a value from 0.0 to 0.99, never ending 9. Okay. And so, okay, that's it. And then since this generates a number between 0.0 to 0.999, and you multiply by 6, this will give you 0, right? And this multiplied by 6 will give you this number. And then let's look at this. What does this do? Num2 will be a number between 0.0 to 5.99999. And then you cast that number into an int. So this cast into an int will be a 0. This cast into an int will be a 5. Remember, cast does not round up. Okay, it will be a 5. And then you add 1 to it. So the range will be from 1 to 6. That's what this is. Do you have any questions, everybody? Okay, just remember, when you have a seed value, it gives you, it starts from 0 to 1 less than the seed value. Okay. And so here we declare a random object, and we use this to generate a number, which is 0 to 5. And then you add 1 to it, right? So now your range is 1 to 6. Okay. And so how do you decide what the seed value is? And I give you, I formalize a formula so that you can you can correctly calculate the seed value. So if you have a range, you say, I want to generate a value from 1 to 6. Then this is the beginning range. This is the ending number for the range. What you do is you do ending minus beginning plus 1 plus beginning. So ending minus beginning, that gives you 5, plus 1, that gives you 6, right? That is your seed value. That's this. Plus the beginning is 1. So plus the beginning. Okay. To generate a number in the range of 5 to 24, you will do 24 minus 5 plus 1. And then add the beginning. So that gives you 19 plus 1, that gives you 20. This would be 20. 10 to 100, you will do 100 minus 10 plus 1, that gives you 91 plus 10. Okay, how about this one, everybody? Let's do one exercise at least today. We'll look at the last one. How do we do the last one? What's the range, first of all?
21, or it's 10 through 21. So it would be 21 minus 10 plus 1.
10 through 21. Everybody, once again, look at this. What's the range?
11 to 20?
Yes, 11 to 20, right? Greater than 10 and less than 21. So 11 to 20. How do we calculate the seed value?
Ending minus beginning plus 1.
Okay, give me the numbers.
Oh, 20 minus 11 plus 1.
Okay, plus 1. That would be the seed value. And then?
And then you'd add 11.
Yes, yes. So this will give you 9 plus 1. That gives you 10, right? Plus 11. So let's look at this. So if you have a ren next int, which is 10 plus 11, okay, this will give you a value between 0 to 9, right? And you add 11 to it, it will be 11, oops, go up. That would be 11 to, we are adding 11, that would be 20. That's correct, right? Okay. So this is how you generate random numbers within a certain range. Any questions, everybody? We don't need to do this, do we? You are all getting it, right? Do you want to do this, or are you okay?
I'm good.
Okay.
Good. Okay. Everybody? Actually, I have the answer there. So but I don't need to go through that. I don't need to go through that logic, right? You understand that, okay? So here, examples. Random exercises. Generate a number between 133 and 275, you will inclusive, you will do 275 minus 133 plus 1, and that's the seed value, and then plus 133. So it's pretty easy. Okay, let's look at the math class. Okay, the math class, so there is a class called math in Java. Remember, Java's class names always start with uppercase letters. So math is uppercase, okay? In Python, it's not uppercase, but here it's uppercase. So there are a lot of methods in math you can use. And here is one. Here is another. You are familiar with square root. Okay, here is how you use the methods in the math class. Instead of creating a math object and use the methods, you simply use the math class name dot followed by the method name. Because all methods in the math class are static methods, which we will discuss in chapter 7. So just know that for math methods, you can use the class name dot method name. Look at random. How do we do a random class? How do we use random? We have to declare, create an object, use that reference variable to call the method, right? Because all the methods, next int, next float in random are not static. So you have to use an object to call it. While in math, okay, all methods are static. That means you can use the math class name dot cause, the method name. You don't have to create an object. That's the difference. So looking at this, you see this scanner, you have to create an object. Use the object to call the method, right? But for math, you don't. You just use the class name dot method name. Class name dot method name. Okay.
And you wouldn't have to import it since it's part of the java.lang, right?
Yes, yes, that's absolutely correct. Yes, you wouldn't have to import it. Yes, very good. A good point. Okay, math.pow. Okay, any questions about this? Good, okay, we go to the next. I'm asking you to do this, but not here, right? You, once again, you look at it and you see if you should be able to do it. Ask the user. Okay, one thing you need to remember is all these methods return a value, and the value returned is a double, not int, but double. And it requires a double also. Okay, the parameters are all double type also. Why can we simply use an int here, everybody? Why?
Because you use the math.pow and the 2 is like to the power of. Does that make sense?
Yeah, but I'm asking you, I said for every method in math, the parameters arguments have to be double. So why can we simply use a 2, not a double, 2.0 or 2.5? Why?
Because an int can be a
I didn't hear you. Say it again.
it'll like temporarily change the int into a double, like 2.0.
Yes, yes, very good. That's called promotion, right? Promotion, yes, promotion, because it's a double, it requires a double, but an int is less than a double. Int uses 4 bytes, double uses 8 bytes. So an int is automatically converted to a double. Why vice versa is not correct. It's not wrong. No, it's not true. Okay, you cannot automatically demote a double to an int. You have to cast it. Remember, just now we had num2 equals to int, right? You have to cast it. But when you put an int into a double placeholder, it works. Okay, that's how you use the math class. Any questions, everybody? No, you see, even though we are going very fast, we still have time for questions. So that's how you learn. If you have questions, don't hesitate to ask. Okay, questions. No. Okay, let's go. No. Okay, let's go to formatting output wrapper classes. Okay. So to format output, you have to import these classes. They are in the text package, I think. Okay. Yes, text package. You import java.text package. And these are the classes that have methods for you to format the output. In Python, you use the %sign to format it right there. In Java, you create objects to call the methods to format it. Very formal. If you look at Java, the syntax is very formal, very disciplined. Okay. So these are some of the methods. This is a method that belonging to this class. This is another method belonging to this class. What this does is it will give you an object so that you can format everything into the currency style. This will format everything into the % style. So you don't have to really remember, okay, I put the percentage here, like in Python, you know, you have to remember exactly here. Let's look at this example. Okay, we have tax rate and scanner, and this is how you declare, right? This is a static method. You don't have to understand that, but just know this is how you get a tool to format. Okay, FM1 format 1 will format into something into currency style. Format 2 will format something into % style. So let's see. You enter a quantity here and you read it, and then you enter unit price, you read it, and then you do the multiplication, and then you do the tax, then you do the total. And here, okay, subtotal is format 1 dot, remember format 1 is an object that will format currency into currency style. Format 2 will format it into % style. Okay, so format 1 dot format, that's a method that belong to that class. So you use the object name dot format subtotal. This will format subtotal into the currency style. And that's that, currency style. And format 1 tax will be in currency style, right? It has the $sign. And tax rate will be in % style because this is format 2. And format 2 is % instance, okay? So here it will format it into %, and that's the % style. And here it's formatted to currency style. That's how you format. Any questions, everybody?
Will it, does it need to be a double? Will it turn an int into a double in that format?
If it's not a double, it will not. It will, that's a great question. I really have no idea. Will it add a double the 2 zeros there? Maybe not, because it's currency style. It's not accounting. Even with accounting style, you still don't have to have decimal places. So I would say no, it doesn't add the double, the 0, 0. Unless your thing has, you see this % style, it doesn't have the 6.0, right? That was the question. So yes. I would say no, but we can, you know, we don't have time, but you can always try it out, right? Copy this code into Eclipse and run it, but I would say no. Okay, let's look at formatting output. Here is another class, decimal format class. I never looked at you, everybody. I'm looking at this. I hope you're all okay and you're all there. So this is the decimal format class, okay? And we use it to format floating point value, okay? So you can specify that the number should be truncated to 3 decimal places. So this is used to really format decimal places. Okay, let's see. I gave you specific explanation here. If you use a 0 in the pattern, it will always be displayed, even if the number has fewer digits. It should be fewer. That's the correct grammar. When you use a pound sign, it's the 0 will be omitted. Okay, this is the pattern. So let's look at this. You have to import it. Okay, just like number format, you have to import it. And the scanner, you create a scanner, you read from the user. Okay, and you read the radius and you do the calculation. See, this is calling the math power. Raise radius to the power of 2. Okay. And then this is called a constant. This is a static variable. So if you want to use pi instead of 3.1415 something, you can use math.pi. Okay. So this is creating a format object, creating decimal format reference variable, an object here. And this is the pattern you want. Remember, this means if it's a 0, it can be omitted, right? You are specifying 3 decimal places, but if the last decimal place is a 0, it can be omitted. That's what that means. Okay, so you use this object name here, use it to format area, and use this object name to format circumference. And what is the formatting? The format is this, 3 decimal places. So here you have this, and here you have 3 decimal places. Okay, let me show you. I did copy this into my code, and I will run it so that you understand it. I am going to, I think, let me see. Yeah, okay. I'm going to comment this all out. Everybody, to comment it out, you press Control-Shift-C. And to uncomment it, Control-Shift-C. Okay, so I will do this one. So I will do Control-Shift-C. And now let's run this one, this method. This is from what we just saw, right? And if you enter 5, and that's what is printed out. See, this is the pattern, right? Okay, if I delete this, I change it, everybody, to this. And let's see. So I'm saying, even if it's a 0, I want it there. Let's do exactly the same thing. Okay, it will give you the 0. So that's the only difference. And that is simply the pattern you want it to show. Any questions about this, everybody? No? Okay. No questions? Okay. The last, what time is it? Okay, it's 11:06. We still have 4 minutes. Let's finish this wrapper classes. Okay. Remember, we said there are 8 primitive data types, right? And these are the 8 primitive data types. So you have byte, short. This is 1 byte, 8 bits. This is 16 bits. This is 32. This is 64. And this is actually 32, 64, 8 bytes. Okay, char is 2 bytes, that's 16. And this is actually just 1 byte, 8. So these are primitive data types. Okay, 1 byte, that's 8 bits. So these are primitive data types. They are built into the language. You don't have to worry about it. You do not have to import anything. It's in the language, native to the language. Well, for each primitive data type, you have a corresponding wrapper class. This is a class type. It's an object, it's a class. And you will ask, why do we need that? And you will see gradually, you will see. Sometimes when you use something, it requires an object, not a primitive data type. When you are in class 3 or 2, you will see that more explicitly, and you will understand it much better. But for now, just know, oh, this is class 2, right? Yeah, later we will discuss this a little bit. But in class 3, especially, you will understand that completely if you go on. So this is corresponding to this primitive data type. So these are all class types. And notice the spelling. The spelling is the same except the first character is in uppercase because all class names start with uppercase letters. And character, care, is different. It's character. Okay, that's the difference. So each native type, primitive type has a corresponding class type. And this is how you declare a variable. Age equals to new integer. That's the class name. And now age will be an object, not a primitive data type value. It's an object. Its value is 40. Okay. Okay. So for these wrapper classes, a lot of them have some static methods. And that's very useful. They are like utility methods because you can do conversion. For example, integer class has a method called parseInt. That means if you give me a string, I will convert it into an int. That's what this is. So if this string is 1, 2, 3, that's a string, right? But now it will convert it into an int and assign it to num. Okay. That's that. So auto-boxing means give me a primitive data type value. I will automatically wrap it up, make it into an object, into an integer object. So let's look at this. Here. Okay, so you declare an object, a reference variable. This is a primitive data type, right? And here you're assigning a primitive data type to an integer object. So it's okay. You do not need to cast. You actually do not need to do this. You can, but you don't have to. You can. This is the syntax, but to simplify it, you don't have to do this. You can simply assign it to this object because this is called auto-boxing. The system automatically creates this object and assign it to it. That's called auto-boxing. Unboxing, okay, the reverse, it's true, reverse conversion, this is called unboxing. An integer object, and you assign 42 to it. What is this mechanism called, everybody? This mechanism. Notice this is an integer reference variable. This is a primitive type, primitive value. And now you're assigning a primitive value to an object reference variable. What is that mechanism called? Right? Auto-boxing, okay?
Oh, okay.
Yes. Okay, you're automatically converting this primitive value into an object. Okay, and here, this is unboxing. This is an integer object, but you're unboxing it, get the value from it, and assign it to an integer, an int primitive data type variable. So you're unboxing it. Here, you're boxing it. Auto-boxing, auto-unboxing. Questions? So this automatically converts an integer object to a primitive int variable. Okay, let's look at this. Is this okay, everybody? Is this a valid statement?
Yes.
Yes, why? What is this mechanism called?
Auto-boxing?
Yes, auto-boxing, yes. And here, this is okay. What is this mechanism called?
Auto unboxing.
Auto unboxing, yes, unboxing. Okay, you are unwrapping a reference variable object, an object, and get the value and assign it to a primitive data type value. Here, you are wrapping this up, make it into an object and assign it to an object, okay? So that's it, everybody. We finished chapter 3. I'm going to stop